We're on lesson 5 of chapter 10, which we're making predictions. First, we're going to use experimental probability, then we'll use theoretical probability, then we'll solve a real-world problem. So predictions, what are they? Predictions is something that you can reasonably expect to happen in the future. Let's use one example. Example 1 is the NCAA tournament that happens every year. All basketball teams in the NCAA tournament are given a seed. For example, this is a 1 seed and this is a 16 seed. If you use experimental probability, a 16 seed has never beaten a 1 seed. So you can say with almost all certainty that the number 1 seed is going to move on and win that game. However, with the 8 and the 9 game, you can never really be sure. It's about a 50-50 chance, actually, that the 8 team beats the 9 team. So you can really just do a toss-up here because you don't really know for sure. I could pick the 9 and not feel too bad about it. The 5 team is better than the 12 team usually, although they only win about 2/3 of the time, if that. So even though I do pick the 5, this is not guaranteed to happen. In fact, actually last year, I believe Harvard actually beat Cincinnati. So it's always a great idea to use probability to help you make your predictions. Same thing with a blackjack game you could be playing. I play this once in a while with my friends. The goal in blackjack is to get as close to 21 without going over. So for example, a jack which is worth 10 and a 7 which is worth 7 is 17 points. Should I take another card? Well, I know there's only 4 different types of cards, ace, 2, 3, and 4, which would keep me from going over 21. And all the other ones would make me go over 21 and make me lose. So the probability of that would be 4 out of a total of 13 types of cards. This is less than a 50% probability, meaning that I probably shouldn't take another card because that'll probably mean I go over. I mean, is there a chance that there could be a 3 or a 4 in the next card? Sure. But if I'm playing the probability, I probably won't take one because it's less than 50%. Let's use experimental probability. So Caitlin finds that the experimental probability of her making a 3-point shot is 30%. Maybe she made 30 out of 100 or something like that. So out of 500 3-point shots, how many could she predict to make? So here we can use a lot of things we learned with ratios in chapter 4 and percents in chapter 6. Her 3-point shooting percentage is 30%, meaning that for every 30 shots she makes, she's going to shoot 100. So if she shoots 500, how many could she predict to make? We don't know how many she's going to make, but we know how much she's going to shoot. So using this percentage of probability, we can make a prediction of how many she's going to make. 100 times m is 100m. 30 times 500 is 15,000. Divide both sides by 100. And that would give us 150 for made shots. So she would make about 150 out of 500 shots based on the probability that we had, which was 30%. Here we can use theoretical probability, which looks at the odds. So if you roll a number cube 15 times, about how many times do you expect a roll of a number less than 6? Using theoretical probability, remember the total number of trials, which would be 6 for a number cube. It could be any number 1 through 6. A number less than 6 could be 1, 2, 3, 4, or 5, meaning 5 total events that could occur. So here's our probability, 5/6. So that means 5 rolls, which would be less than 6 out of 6 total rolls. And we can line that up with 15 total rolls. How many times are we going to expect to roll less than 5? And we can use the same formula. 6 times t equals 5 times 15, which is 75. Divide both sides by 6. And that's going to give us t equals 12 and a half. Well, we can't roll a number less than 5 a half of time. It would have to be either 12 or 13. So for this answer, we could say 12 or 13 times. About that. Now we can solve a real-world situation. It says the Wettermark family is planning a 14-day vacation. They would like to go to Pensacola, Florida sometime in July, August, or September. Pensacola averages 19 rainy days during those 92 days. If the Wettermarks would like no rain on at least 10 days of their vacation, should they go to Pensacola? So here it gives us the experimental probability. It tells us how often it rains in the past. So that'd be 19 out of 92 for our probability. That means it rains 19 times for every 92 total days. The Wettermarks are going on vacation for 14 days, so their total days are 14. So how many days is it going to rain for them? So 92R is equal to 19 times 14. 92r is equal to, this is 266. Divide both sides by 92 to get r by itself. So the number of rainy days for their 14-day trip they could expect would be 2.891, so 2.89. So are they going to have no rain for at least 10 days? Well, if there's 14 total days, subtract 2.89, that would give us 11.11 days without rain. So they can expect about 11 days without rain. So should they go to Pensacola? We would say yes, because there is at least 10 days of their trip without rain. So that'd be yes.